In this lesson, we'll go over proportions. Your icon at the top here is the Vitruvian Man by Da Vinci, because he used proportions when making this picture. And also we're going to talk about a little bit different but related an architecture application problem later on. So in this objective, or in this lesson, we'll understand proportions. We'll learn how to determine if proportions are true or false. We'll learn to find the missing value or solve proportions, and then we'll use proportions to solve application problems. So to get started, fractions, just kind of a review of things that are related to proportions. Fractions are number of parts over number of parts in the whole, so if you eat 1/4 of a pizza. A ratio is a comparison between two numbers. So if you're making rice, it's a 2-to-1 water to rice ratio. So for every 2 cups of water, you would use 1 cup of rice. Proportion is when you have a fraction equal to another fraction. So if you use the ratio about water to rice, if you're cooking 4 cups of rice, how much water do you need? You could scale it to whatever number you need, and that would be a proportion when you set up a fraction being equal to another fraction. Okay, so example 1, so determining true proportions. There's a few ways to do this, so I'll talk about how to do that. Okay, so first, 1/2 equal to 7/14. You might know that that 7/14 is the same as 1/2, so this would be a true proportion. But take a look. If you can multiply, so to get from 1 to 7, you multiply by 7. To get from 2 to 14, you also multiply by 7. So if you're multiplying and dividing the same number for the numerator and denominator of one fraction to get to the other, it's a true proportion. The next one I'll show you dividing so this doesn't get too messy. Another way to do it is to cross multiply. So we would take 1 times 14, and then you do your equal sign, and we want to know if that's equal to 7 times 2. If we get 14 equals 14, a true statement, then it's also a true proportion. So you can use a factor to see like if you're multiplying the numerator and denominator by the same thing, or you can use cross multiplication. In example B, to get from 5 to 1, we divide by 5. It's always multiplication and division, by the way, never addition or subtraction, because when something's like, when you're using a proportion or when you're scaling, it's always by like a factor of 2, or you're reducing it by half. So it's always involving multiplication or division. 100 divided by 5 is also 20, so this would be a true proportion. Okay. In example C, if it's not completely obvious how to get from one to the other, take the bigger number and divide it by the smaller. So 6.5 divided by 5 is 1.3. So you can think of this in two ways. 5 times 1.3 is 6.5, or 6.5 divided by 1.3 is 5. So you can use multiplication or division. Okay. So I'm going to say this is times 1.3 times 1.3. So this would be a true proportion. And again, you can also cross multiply. If you were to cross multiply, you would want to determine if 5 times 10.4 is equal to 6.5 times 8. Okay, when you're cross multiplying, you're taking the entire numerator times the entire denominator, cross it, put your equal sign, and then determine if the other numerator times the other denominator to see if those are equal. If we put that in our calculator, we would get 52, and then 6.5 times 8 is 52. So yes, these are true proportions. Let's just show a quick example of a false proportion. Okay, so a couple of things here. You could multiply by 5, but if you take 2 times 5, you would actually get 10. So this is not a true proportion. Okay, the other thing is if you were to cross multiply, 5 times 2 is 10. That's not equal to 8. So this would be a false proportion as well. Same thing like, let's say we had 1/2 equal to 4 over 5. You may notice that this is plus 3, but we're talking about multiplication and division here. This would be 5 equals 8, which is not a true proportion. Okay. Solving proportions. So whenever we're solving, we're always finding the value of the variable that makes the equation or the proportion true. There's multiple ways to solve, and then there's also ways to check your answer. So first, x over 7 equals 39 over 91. For this type of problem, we can say, okay, we see the two denominators here. We can take 91, divide by 7 to determine what we're multiplying or dividing by. is 13. Okay, so 91 divided by 13 is 7. So we could take 39 and divide it by 13 as well to come up with x. If we take 39 divided by 13, we get 3. So that means we're saying 3 over 7 for x is equal to 39 over 91. And you could check it using what we know about true proportions with cross multiplication. Okay, the other way you could do this is to solve it algebraically, which will come up in the next section or the next example, by cross multiplying. So I'm going to rewrite the problem. So to cross multiply, we would take the entire numerator times the other entire denominator to get 91x. Then we would do 39 times 7. Okay. So now we would have 91x is equal to 39 times 7, 273. So what this equation becomes is 91 times some number is equal to 273. To solve, 91 is being multiplied by x, so we divide both sides by 91, which means that x is equal to 273 divided by 91, which is still 3. Okay, so two different ways to do it. You can take a look to see how to get to a true proportion, or you can use algebra. In example 2, you have to use algebra. Okay, so we'll go through this one together. This one we're going to cross multiply, so we would do x times 2 to get 2x. And remember, when we're cross multiplying, it's entire numerator to entire denominator. So we're multiplying 3 times x plus 4. So the 3 has to go to the x and to the 4 to get 3x plus 12. And now when we're solving, our goal is to find the value of the variable that makes the equation true. A helpful way to do this is to get our x's together and our numbers together to solve for x. So I'm going to subtract 3x from both sides. 2x minus 3x is negative 1x. Bring down your equal sign. 3x minus 3x, those cancel out, and we're left with 12. To get x by itself, we divide both sides by negative 1. We get 1x is equal to negative 12, or just x equals negative 12. And you can plug that in to check to make sure it's a true proportion. Okay, similar thing here. I'll get this one started, and for sake of time, I'll get this one started, and then I'll leave it to you to solve the rest. Okay, see, we would do 43 times 13 is equal to, the 65 has to go to the 9 and the x, so 65 times 9 plus 65 times x would give us 559 equal to 585 plus 65x. Actually, I'm going to solve this one completely. Okay, and so we get x by itself, so we need to move the 585. Okay, so on the left-hand side, we're taking 559 minus 585 to get negative 26. This is equal to 65x. From here, 65 times what is equal to negative 26? So we use division. And depending on how the software wants your answer, you could either enter this fraction, try to reduce the fraction, or if you plug in negative 26 divided by 65 in your calculator, you would get x is equal to negative 0.4. It's okay to get a decimal or a fraction as an answer. That's why I wanted to solve this one completely. So application problems, so proportions can be helpful for solving applications. At your job, you make 500 every 2 weeks. How much would you make in 6 weeks? So I'll draw this one out. It may be intuitive as to how to solve this, but I'll also show you how to solve it with a proportion. Okay, so what the first statement is saying is you make $500 every 2 weeks. If you want to know how much you would make in 6 weeks, well, we would need another 2 weeks and another 2 weeks to get 6 weeks total. And we're making 500 every 2 weeks. Okay, so we would add these up to get 1,500 in 6 weeks. And you may have known to just take 500 times 3. If you're going to set up a proportion, you would set up 2 fractions and use x for the missing value. So for instance, I'm going to choose dollars and weeks, and you have to be consistent. So I make 500 every 2 weeks. So notice for the other fraction on the right-hand side, I've also set up weeks, dollars to dollars, weeks to weeks. Okay, so we're saying that the two fractions are equal, so it has to be the same units on top and bottom that we're talking about. We want to know how much you'd make in 6 weeks, and then question mark or X for the unknown. And for this, you could cross multiply or see, okay, 2 times 3 gives me 6, so 500 times 3 will give me the value that I want. Application number 2, on an architect's blueprint, 1 inch corresponds to 6 feet. If an exterior wall is 62 feet long, find out how long the blueprint measurement should be. Write your answer as a mixed number as necessary. Okay, so we're going to set up a proportion. The first piece of information we're given is that 1 inch is equal to 8 feet. So I'm going to write 1 inch, 8 feet. Okay, an exterior wall is 62 feet long. So now we want to determine, does the 62 go in the numerator or the denominator? It has to go in the denominator because feet has to correspond to feet. Okay, and we don't know how many inches that should be. So for this problem, again, you can use cross multiplication, or I'm going to take 62 divided by 8, which is 7.75. And so that means that 8 times 7.75 is 62. So I would take 1 times 7.75. Okay, so 7.75 inches. But this problem is talking about a mixed number, which we haven't talked about before. So there's a couple different ways to get there. There is a button in your calculator that'll do it. If you're curious, stop by office hours or email me, or you may already know the button. There's a couple of other ways to find it. So 7 is the whole number. So we write a big 7. 75 ends in the hundredths place. So this would be and 75 over 100, and then you would reduce the 75 over 100 to 3/4. You may already know that 0.75 is 3/4, so you could go about it that way as well. If you were to use long division, let me break this up. You would take 62 divided by 8, so you're seeing how many times 8 goes into 62 without going over. 7 times 8 is 56, and if we subtract, we get 6. So 7, again, would be the big number because 8 goes into 62 7 whole times, and we're left with 6 over 8 as our remainder, and then you reduce that fraction as well to get 7 3/4. Okay, so I just wanted to talk about that. It may already be something you're comfortable with, but I don't believe we've discussed the mixed numbers so far. Thanks for watching. If you have any questions, please let me know.